everyone. And this is Dr. J. Sirisha Devi, working as Associate Professor in Institute of Aeronautical Engineering. Today we are going to see the concept of circular queues. What do you mean by a circular queue? Before that, let's revise few things which we have learned in the earlier sessions of mine. Mean what a queue is first of all. Forget about circular queue right now. First of all, recollect what a queue is. Or you can even say what a linear queue is. Right? What does you mean by linear queue? It is a data structure, linear data structure in which data is stored in contiguous memory locations which have access at both the ends but restricted access. In what way it is restricted is we can insert the elements at the rear end and we can remove the elements at the front end. So we cannot perform both the operations at both the ends. No. Right? So such a queue is a linear queue. So what was the drawback that we have seen? So let me draw a rough sketch. Suppose this is your queue, linear queue. So I will complete it. So yes, this is your linear queue, right? So you have inserted few elements and deleted after few insertions and deletions. This is the current status of your queue. Let's see. 4, 5, 7, 9 are the elements. Then what will be the position of your front and rear pointers? So front will be pointing to 4 and rear will be pointing to 9. Am I right? So the elements were inserted like this. After due course, this is a snapshot of a linear queue at certain point of time, right? So I want to enqueue 11. I want to insert 11. Is your queue going to allow me? The condition is to check whether the queue is full or not. R is equal to n minus 1, where n is the size of your queue. Right? So, if you look at this one, yes, rear is pointing to the last element, or you can say the last position in your queue. So, it simply says that no, I am full, I cannot insert, I cannot take any more element, I'll overflow, right? But if you look into it, the 3 spaces before the front are vacant. Am I right? So if I even fill it with the index value 0, 1, 2, 3, 4, 5, 6, right? So rear is pointing to the highest index value and it will say that if you try to insert, I'll overflow. So, but index values 0, 1, 2 are vacant, right? So, this is the basic drawback of a linear queue. Even the space is there, it doesn't allow at times. To overcome that, circular queues have come into the picture. Then, how they are different from an ordinary queue or a linear queue or a simple queue is they will be, yes, circular queue is also a queue which have the property of first in, first out, which works with 2 pointers front and rear. Whole story is the same, but the connectivity changes. Means, after the highest index value, the queue will be connected to the 0th index value. Have a look at the picture. It will be circular in fashion. If you can look at this one, so you are going to travel in this direction 0, 1, 2, 3, 4, 5, 6, 7. So you need not think, you need not get discouraged. So even the last one is connected to your 0th index. So this is the beauty of your circular queues. So if you look at this one, so the elements which have been entered are 10, 20, 30, 40, 50. So what if you insert, let's do few operations on the same. Let's do, yes. So I have inserted 60. So my rear is pointing to 60 now. Then I'll perform an insertion of 70. Now your rear will pointing to 70. Then I removed 10. So my front is pointing to 20. Again, I remove 20. This will be pointing to, front will be pointing to 30, right? So again, I am going to go for an insertion 80. Rear is pointing to 80. Again, if I want to insert 90, if this was a linear queue, it would have objected me saying that my rear's index value is the highest index value, the max index value which a queue can accommodate. I cannot insert, I cannot entertain you, right? But circular queue will not tell that. It will check whether the 0th index is the front holding the 0th index. If not, it will change the position of rear to 0 and it will help me to insert the element. It will help me to insert the element. Yes, don't worry guys, I'll show you everything with animations. So this was just a glimpse or an basic introduction of your circular queues. Okay, so this is how we are going to see. These are the things that we are going to see in a circular queue. NQ, DQ, front, rear, is full and is empty. These are the 6 basic operations. The same old operations which we have performed on a linear queue. NQ is nothing but inserting an element. DQ is deleting an element. Front, to return the element pointed by the front. Rear is to return the element pointed by the rear. Is full and is empty are going to check whether the queue is full or not respectively. Right? So as the first index is connected, or you can say 0th index is connected to the last index, we do have few more conditions to check. Let's see. Yeah, guys, this is an empty circular queue. Guys, I have taken this picture in a linear fashion because even in memory internally, circular queue doesn't mean that you will have something circular in nature. No. But it will use the funda of connecting 0th index with the maximum index. Let's see this. Initially, the front and rear in an empty circular queue will be at positions -1 and -1. What will happen if I try to insert or NQ6? As front and rear both are at -1, both will be incremented and both will be pointed to 6, that is at index 0. Then I perform insertion of 12, in which end we are going to insert rear end. So increment the rear, insert the value. Next, NQ operation, simply inserting the rear and shifting the rear and inserting the elements, right? So 11, 7, 14, 10 I have inserted. So with 11, rear will be incremented with 7, 14, 10. After inserting these 4 elements, this is the current status of your circular queue, right? So if I try to insert an element, it will check 2 conditions because this is a circular queue. One condition is our basic condition of our linear queues, which says is R pointing to n-1, that is the maximum index. And a new condition which raised is the front pointing to 0th element, 0 indexed element. Yes. So you can see that both the conditions got satisfied, right? Both the conditions got satisfied. So overflow condition raises and it says that it cannot insert or NQ. So let's see deletions. In which direction you are going to delete? From the front end we are going to delete. So let's do 3 deletions. That means remove 6, 12 and 11. When we remove that from the front end, this is the current status of your circular queue. Your front is pointing to 7 and your rear. So at the time of deletion, rear, there will not be any change in the rear, right? So unless only the element which you are removing is the only leftover element in your queue, rare's pointer will also be changed as -1. Unless that case, in all the remaining cases, we are not going to touch the rare value, right? So this is the current scenario. Let's see what to do. NQ71 enough. Now try to insert an element. It's very easy. The rare will check. What are the conditions it is going to check? Front is equal to 0 and R is equal to n-1. Yes, R is equal to n-1 is satisfied. But what about F is equal to 0? It failed because F is pointing to 3. So, as the condition of overflow failed, R will be pointed to 0 and a new element will be inserted. Yes, you can see previously in linear queue, always rare was ahead of front, or you can say front was behind rare. But the story can turn tipsy-turvy in case of circular queues. Now you can say R is behind F. Pictorially. I'm just saying it pictorially. Okay. Yes. NQ two more values, 6 and 21. So, rare and we are going to insert. So, rare will be incremented to 1 to insert 21. Again incremented and rare will be 2 to insert 6. This is the current position. This is the current circular queue. What will happen if I try to insert 11? It fails. Why? One more condition of overflow. F is equal to R plus 1. That means if the rare sees that front is just ahead of it. If rare sees that front is just ahead of it, one step ahead of it, it says that I cannot insert. Overflow condition raises. So, there are many conditions which you need to check. One is we cannot see. That means accumulative of overflow conditions is if F is equal to 0 and R is pointing to n-1 is the one case when overflow condition raises, and the second is when front is equal to rare plus 1. Front is equal to rare plus 1. If any one of these conditions gets correct, true, if any one of these conditions is true, then we can say that overflow condition has occurred, insertion is not possible. Okay, I hope you understood that. Let's see algorithms for the same, right? Pieces of pseudocodes for the same, right? Insertion, as I said, to insert we need to think of two conditions. Front is equal to 0, rare is equal to -1. A combination of this must be true, or front is equal to rare plus 1. Either one of them can be true. This is one condition. Cumulatively, this is one condition, or this is the second condition. If either one of the condition is true, we say that the queue is full, overflow condition, and it is going to return. Okay. Second case will be a case where rare is pointing to -1. When rare will point to -1? When the queue is empty. As I'm talking about insertion, my point of view is regarding rare. You can even write it as front is equal to -1 also. Even that is true. Because when Q is empty, both front and rare will be having -1, right? In that case, when rare is -1, change the index values of both front and rare to 0. Change the index values of both and front to 0, or increment, you can say. Increment it. Okay? Else, if rare is equal to n-1, then shift rare to 0. This is case 2. If rare is equal to n-1, shift rare to 0. If all the odds are not there, it's a normal scenario, then rare, it gets incremented normally. And the operation that you have to perform is insert the element at the rare position. I can say that this is the case of failure or a case where we cannot insert, and these are the cases where we can insert, we can perform the operation. And in that we have three cases: when the queue is empty, case where the rear is pointing to n-1, and a general case. Three cases. Okay, so remember guys, for an overflow condition, you can encounter either one of the two cases. One is front is equal to 0 and rear is equal to n-1, or the front is one step in front of your rear. So front is equal to rear plus 1. Even in that case, overflow condition rises and we cannot say that we can insert, right? So this is your insertion. Next one, deletion or DQ operation. If front is equal to -1, why ma'am front? As I said earlier, even you can write rear is equal to -1 also. That tells that basically the queue is empty, your circular queue is empty. So trying to remove something from an empty queue is underflow condition. Underflow and return. So I just want to show which element I am going to remove. So the element which we are going to remove will be at the front end. So I'm going to store it in the variable item. That's it. Okay, just to show, right? So then comes the cases of deletion. What if front is equal to rear? What does this mean? Last element. Or, okay, I will not even write last. I'll just say that only element. Okay, only element left in the stack. Only one element left in the stack. What will happen if you remove the only leftover element into the queue? Inside the queue, you have only one element and you have removed it. What will happen to front and rear? They'll come to their default values -1. They'll come to their default values -1. That is case 1. Second case, where your front is not equal to rear, that is, you are not trying to remove the element which is the only element in your queue, right? Sorry. You are trying to, now this is the case where you are not trying to remove the only leftover element in your queue. A normal case where if your front is pointing to n-1, look at the picture, your front is pointing to n-1. That is the highest indexed value. At that time, when you remove that element, your front will again come to 0 and point like this. Right? So make front is equal to 0. Else, a normal case, increment the front, remove the element. Right? So I can broadly classify this into a case. If front is equal to -1, it is a failure case, and these are the success cases. Removal, where front is equal to rear means I am trying to remove the only one element, leftover element in your queue, or a case where your front is pointing to the last index value so that I can bring my front to the first index, that is 0th index. A normal case, incrementing the front. So there will be three cases in case of deletion, successful deletion in case of a circular queue. Right? So what are the operations we are left with? Is full, is empty. So when just combine the cases that you have checked for overflow and underflow. It is overflow. When you say that it is overflow, when the queue is full. So what are the conditions for the full case? Very simple. Front is equal to 0 and rear is equal to size -1, or front is equal to rear plus 1. Right? That is the two cases where you can find that the circular queue is full in nature. Empty, any one of the condition will be enough. Either front is equal to -1 or rear is equal to -1. Okay, so these are the 4 basic operations. Then let's say traverse. Traverse means displaying all the elements in your circular queue. Let's see. Let's start this with this one. What if your front or rear is pointing to -1? It is an empty circular queue. I cannot display anything, right? So queue is empty, so return. So then comes a success case, a case where I'm going to actually print something, right? Guys, this is a piece of Python code. Okay, right. So there will be 2 cases. What did I tell you? In case of linear, always rear will be ahead of your front. But in case of circular queue, the story can change, right? So let's say the first case when rear's value is greater than or equal to front. Then print the value from front to rear placement. Else means a case where front is ahead of rear. So this is the case, guys, for this else part. The picture goes like this. You can see that the value of front is 3. The value, index value I'm talking about, rear is 1. So the value of front is greater than rear, which is the else part. Then how you have to display the queue? Very simple. From 0 to rear, and then from front to n-1 index values, right? So this is the content which we have to print, and the Python code for the same is given below, right? So these are the, yes, in a linear queue from front to rear, job done. All the contents will be between front pointer and rear pointer. Job is done. But here you can have, in the first case, as you can see, from front to rear, you can have, or your list may look like a splitted one, right? But in real scenario, as your 0 is connected to 5, but logically it's not, right? So we have to write 2 for loops to run, right? From 0 to rear and from front to your n-1. That is the maximum index value. So this is the traverse operation for your circular queue, with which you can see that circular queues are queues which overcome the problems of a linear queue. The basic problem of starvation in linear queue, they overcome that. But still circular queues suffer. Do you know why? So the reason is very simple. Very simple. So if you are trying to search for an element, or you can see that the basic constraint of linear queue and circular queue is their accessing is been splitted. At front end you can remove, at rear end you can insert. Their access rights are being limited, right? So what if you want to delete an element, a particular value which is at rear end? How? Queues do not allow you to do any intermediate things, right? So what to do? Rear point is meant to insert. For in the scenario, look at the picture. If I tell you to remove 21, is it possible? You can remove only the elements at the front end, and saying that we cannot escape the situation, right? So to overcome such scenarios, double-ended queues came into the picture. Double-ended queues are the queues which allow both the operations at both the ends, which we are going to see in our next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.